So, before we proceed into solving oblique spherical triangles, I want you to memorize the following. First, the law of sines. Take a look at it. And then the law of cosines, we have 2 for angles and for sides. What's important in this law of cosines is that these two should not be the same with this. You have to remember that this side should correspond to this angle, and then these two sides are the same, and the same for this one. The angle corresponds to the side, and then these angles are the same. So do not proceed until you are very familiar with these, because you will be needing this in solving spherical triangles that are oblique. Okay, we are now given case 6. This is more or less similar to case 5, but the difference is there are two angles given in the side opposite of one of them. So in this case we have angle A and angle C, and another side which is opposite this angle C. So the procedure is more or less similar. Use first the sine law in order for us to solve for this A. Okay, 79 degrees 37.3 minutes equals sine of this small c over sine of big C, sine 150 degrees 42.7 minutes all over sine 145 minutes 52.2 minutes. And then solving for A, of course, transfer this to the other side using algebra, and then arc sine of A, you will get two values, one acute and one obtuse, the supplement of this acute angle. So let us write it down here, 120 degrees. I hope it's clear for you that when you use arc sine, you will obtain two angles, one in the first quadrant and one in the second quadrant. Okay, let's now proceed. I want to use this first, so I'll find this set, this first set. So let's use the law of cosines for angles, so that we'll be able to look for the side B, and then be familiar with the formula. Cosine of one side times the other side, cosine of the other side, which is 150 degrees 42.7 minutes, plus the sine of 120 degrees 56.8 minutes cosine 150 degrees 42.7 minutes times the cosine of the side we're looking for. And then let's now use the second one, the law of cosines for sides. And then we now put the negative cosine of this one, the angles. Remember, if this is side, use the sides here, then the angle at the end. If you use the angle, you put here the given angles. Okay, that's just a friendly reminder to facilitate things for you. And then remember the negative sign here for law of cosine for sides. Okay, let's continue in this 79 degrees 37.3 minutes sine 145 52.2 minutes times the cosine of small b. And then you'll notice that there are two unknowns, but you can substitute this one here. Yes, yes, of course. So, after substituting, I know you can do it already, but I just want to show you the answer to check yourself. Okay. (56.8 minutes, 40 degrees, 42.7 minutes times the negative cosine of 79 degrees, 37.3 minutes, cosine of 145 degrees, 52.2 minutes, all over. Yes, I'm sorry, it's very long and my handwriting is quite bad, please bear with me. Okay, 1 minus sine 59 degrees, 3.2 minutes, sine 150 minutes, 42.7 minutes, sine 79 degrees, 37.3 minutes, times sine 145 degrees for 52.2 minutes. That's quite long. So you now put this in your calculator. Yes, take a look at it. Okay, more slowly. So you now put this in your calculator and get the arc cosine, and then you will get for B. Do you know? It's 48 degrees, 19.12 minutes. So let's put it there. 48 degrees, 19.2. I mean 19.2. I'm sorry. This is 19.2. 19.2. 19.2. And then after that, you substitute it here. See? This one big thing. Substitute it here. And then you will get cosine of B, and then get the arc cosine of that, and then you will obtain this 58 degrees 55.4 minutes. Yes, okay. And then you write it here. So 58 degrees 55.4 minutes. So now I leave to you the last set of triangles. For your exercise, remember, if you get a math error somewhere, it means that there's no solution. But I assure there is a solution, because I'll give you the answer. So for this one, 20 degrees 9.4 minutes, and then for these 97 degrees 21.4 minutes.